So in this video I'm going to discuss with you how to calculate a missing angle in a right angle triangle. So far I've made two other videos based around this topic. We've looked at one of how to label the sides in a right angle triangle, and in the previous one we looked at how to find a missing side in a right angle triangle. So now we're going to look at a missing angle. The steps, thankfully enough, are pretty much the exact same. So if you have watched the previous video, you should be up to speed with the different steps that I talked you through. First step, we are going to label the sides of my right angle triangle. Start off with my hypotenuse, which is opposite the right angle. The side opposite the angle, which I'm trying to find, is called O. And the other side, that's the opposite, and the other side is the adjacent, which I'll label with an A. The next thing we do is we circle what we know and what we're trying to find out. So I know that the hypotenuse is 10, I know that the opposite is 4, and I'm trying to work out the missing angle. The missing angle will generally be labelled, it might be A, B, C, D, it might be an X, it might be alpha, beta, etc. Just some way of showing that we don't know what it is, it's an unknown at the moment. That's my first step. My second step is that was my second step. My third step is that I work out what trig ratio I'm going to need. So again, for anyone who has forgotten, we use SO, Ca, TOA. So we look at what we've circled. We've circled an O and we've circled a H. So therefore, what I'm trying to work out is going to require the sine ratio. So I'm going to come and write that down as I always do. Sine x is equals to O over h, and now I'm going to fill it in. So this time x is not going to be just x, we've actually been given a different name. So sine alpha is equals to O, which is 4, and h, which is 10. At this point, we're thinking, okay, my unknown in this question is alpha, which I'm trying to get by itself. But how do I get rid of the sine? So, what we have to do, like we did in algebra all the way along, is we're trying to find the opposite or the inverse of sine. But we've never learnt that before. We know that the inverse of addition is subtraction and that the inverse of multiplication is division. But what is the inverse of sine? Well, luckily enough, it's very easy to remember. The inverse of sine is sine inverse, which you'll see written on your calculators as this sine minus 1. So what you need to do at this point of your question is you need to then say, right, I need to get rid of sine. What's the opposite of sine? Look in your calculator, and above the sine button you'll see sine minus 1, and that's what we need to do. So onto your calculator then, I want you to type in sine minus 1. The way that most calculators work is you press the shift key and then you press sine, and on your calculator screen you'll see sine minus 1, and then we need to do into the bracket that you'll see come up on your calculator, do 4 over 10, close the bracket, press equals, and you will get an answer hopefully of 23.57817848. Do we write that all down? No. If this was on an exam, they would have told us to round everything to the 2 decimal places or perhaps the nearest degree. In this case, we'll just do it to 2 decimal places, so it's going to be 23.58 degrees. Remember, it's degrees in this instance because we're finding a missing angle. Okay guys, so if you feel confident, why don't you start by having a go at trying to work out angle A. Pause the video and check, and if you then want to go on and try and work out angle B. So in this question, what might catch people out is that we're being asked to find 2 different angles. Some of you may have already started thinking, well, if I work out one angle and I know that I've got a 90-degree angle here, I can just add them together and take them away from 180 and it'll give me the right answer. So you'll see that these are actually straightforward enough once you get into them. But let's start off with angle A. Let's forget about angle B for a minute and just treat this like all the other questions. We're trying to work out angle A. Step 1, label my triangle. Opposite my right angle, we call that H for hypotenuse. Now, because I'm starting with finding angle A, I need to go to angle A and work out which is the opposite. So in this case, it's here. And then we want to label the other side, which is going to be side A. But just be really careful, because if you were trying to work out angle B, then the 16 would actually be your opposite, if that makes sense. I'll explain that in a minute again. So we're going to go and then circle what we know and what we're trying to work out. Now remember, for this one, we actually have lots of stuff that we can use, which is fantastic. So we're going to start off with circling what we want to know, which is the angle A. And what do we know? Well, we know that O is 30, we know H is 34, and we actually know that the adjacent is 16. So we're really lucky in this one that actually we can use any one of SOHCAHTOA. The reason I can use any one of SOHCAHTOA is because I have all of the combinations. I have an O and a H, I have an A and a H, and I have an O and an A. A lot of the time that won't be the case, but I just wanted to show you this example where you actually had a bit of choice. Let's just go with K for this one. So we're going to write down cos A is equals to A over H. Now sorry, just remember that A in this case is my angle A, this other A is the adjacent. So cos A is equals to A over H. So A in this case is 16 and H is 34. Remember, we want to get A by itself, so we say what's the opposite of cos? It's cos inverse, or cos minus 1, as we see it on our calculators. So all you guys need to do now is on your calculator do shift cos, and you should see cos minus 1, then do your fraction button, 16 over 34, and that gives me an angle A is equals to 61.9 degrees. I've rounded that to 1 decimal place. Now, just to explain what I was saying about whether we started off with angle A or angle B, I'm going to draw this triangle out again, slightly smaller. And this time, we're trying to find angle B. The reason I'm redrawing it, and I would always recommend students to redraw it if you're trying to find more than one angle in the same triangle, is because our labeling is going to be different. So my hypotenuse is still my hypotenuse, but remember, we're trying to find angle B now, which means that the side opposite B is 16. Whereas if you look up to this example, that was the adjacent, because we were trying to find the opposite angle. And the side that's left over is the adjacent. Same thing goes, you're going to circle what you know and what you're trying to work out. So we're trying to work out B, and we know A, we know H, and we know O. So we're lucky again in this one, we know all of the combinations, so we can either go with SO, CAT, or TOA. Let's go with TOA for today, which is tan. So we're going to say tan B is equals to O over A, which means that we need to find 16 over 30. And then we ask ourselves, okay, well, what's the opposite of having, or the opposite of tan? Well, it's going to be tan inverse. So B is equals to tan inverse 16 over 30. And that is going to give us B is equals to 28.1, and again that's rounded to 1 decimal place. Now for anyone out there who's thinking, okay, well, is there any way I could check my answer? Well, we've worked out angle A already, which was 61.9. I've just worked out angle B, which is 28.1. If we add those two together, you're going to get 90 degrees. And we know that our right angle triangle is also 90. 90 plus 90 gives me 180, which is how many degrees are in a triangle. So we know we've done it correctly. So guys, have a go at this last question for me in this video. I would like you to work out angle A. This is a right angle triangle, even though it might not look very like it. So again, remember your steps. Label, pick your ratio, fill it in, inverse to get your final answer. Right, so I'm going to label this really quickly. So I've got H, I've got O, and I've got A. Now I'm going to circle what I know and what I'm trying to work out. So I know the adjacent is 24, I know the hypotenuse is 51, and I'm trying to work out angle A. Think of my SOHCAHTOA again, and we think to ourselves, which one of these has an A and a H? So CAT works. So we're going to write down cos A is equals to A over h. Therefore, A, we know in this case is 24, and h is 51, and we've got our angle, which we've just called A. How do I get A by itself? Well, I need to get rid of the cos. What's the opposite of cos? It's cos inverse. So we're going to do cos inverse, or cos minus 1, of 24 over 51. We're going to pop that into our calculators. So we press shift cos, we create our fraction 24 over 51, and we're going to round this to 2 decimal places. So that's going to give me an angle of 61.93 degrees.